Hey guys, welcome to another day of math. I'm super excited. Today is going to be so much fun. As you can see on the board, we do have another task. So we're going to go ahead and get started with that. Could I have a volunteer please read the problem? Yes, Jamie, you go right ahead. Awesome. Thank you so much. Okay. So before we start diving into the problem and just kind of what it's asking, I wanted to ask first, does anybody have any clue as to what a phonograph record is? That's what I thought. Okay, so a phonograph record is very, very similar to a radio or a CD player in a sense that you had this record and you had to place it on the phonograph and it started to spin and you could put a needle down and listen to music that way. So I'm going to play you a quick clip just showing you what a phonograph looks like, how it works, just so you can get a better idea of what we're dealing with in our problem today. So let's watch. And music. Yeah, so that is how a phonograph works. And I wanted to talk about the record itself because I know they don't really they're not really around as much as they used to be. So this is what a record typically looks like. It has a middle part. This is the center of the record, and then it has this middle part, and then it has this outer part that has the grooves in it. So with a phonograph, the way that music is actually created is that little needle comes down, and while the record is spinning, it actually sits in the grooves that you can kind of see here on that record, and that's where the music comes from. So, today we are going to be talking about these records. And the question itself does ask us, how long is the groove on one side of a long play phonograph record? So right now though, I want to focus a little bit more on some of the assumptions that we're making with the record just to kind of clarify some things, okay? So we are looking at a record very similar to this here in our problem today. So it's a single recording is what it says, and that just means that there is only one recording on that record. So there are typically multiple recordings on a record and things like that, and there's two sides, but our problem's already told us to do one side and then it's a single recording. Okay? So it tells us that the outer groove is 5.75 inches from the center. All right, so let's stop there for a second. Where do you guys think that outer groove is located? Can anybody raise their hand and tell me? Donovan, yes. What do you think? Okay. So Donovan suggested that it starts here. It's this black area. Does everybody agree with Donovan? Okay. So, yes, Cindy, did you have something to add? Yeah, so Cindy brings up a great point. It says that the groove is from the center, okay? So Donovan and Cindy are both very right. This outer groove is that black part, right? So, but it's saying it starts from the center, okay? So where is the center of my circle? Is it this yellow part? No, right? Right, so where is the center? Good job, right there, correct. So it's that white circle here in the middle is the center. So it's saying that my outer groove is 5.75 inches from the center. So how would I measure that 5.75 inches? What is that going to represent? Yes, William. Exactly. So it's going to reach all the way out to this outer part here, right? And I apologize for my drawing. We love working on computers. Alrighty, so that is my outer groove, right? Okay, so then it talks about the inner groove is 1.75 inches. So knowing what we do about the outer groove, what do we think is going to represent the inner groove? Katie, yes. Right, it's the yellow part, exactly. It's this yellow area here that's going to be our inner groove. And so how can I represent that 1.75 inches on my drawing? On my picture here, excuse me. Yeah, you guys are all right. So we're going to draw from the edge to the center as our problem instructs, right? And that's going to represent that 1.75 inches. You guys are exactly correct. Okay. So now that we have an idea of what our record looks like and just kind of lengthwise what we're dealing with on our record, let's talk more about the main goal of the problem, okay? And actually, before I say that, it does also mention that the recording plays for 23 minutes. So that is going to be important information that I definitely don't want you guys to forget. So just remember it plays for 23 minutes, okay? So now to the main part of the task. So someone, I believe it was Jamie earlier, read that it was how long is the groove on one side of a long play phonograph record, okay? So I want to look at this 33 1/3 RPM. All right, does that RPM remind anybody of something that we worked on last week? Maybe something to do with rates? Yes, Jeremy. Okay, miles per hour. Yeah. Can you maybe elaborate on that a little bit? How do you think those are similar? How is that a rate? Okay, good. Yeah. Very good. It has very similar the 3-letter standing. That's very good. Can anybody give me the definition of a rate? Do we remember what a rate is? Right. It is a ratio of units, right? It's kind of a comparison of units. So, it is a ratio of quantities that have different units. So I see that you guys read the definition. Can anybody put that in other words? Is there another easier way to say that? Okay, Cindy, you go. Yeah, exactly. It's kind of comparing those two different quantities, right? So what is a quantity? It's just kind of a way to measure thing, right? Perfect. You guys are doing great. So when we're talking about miles per hour, we talked about how we're measuring the number of miles that we're traveling in an hour. So what do you guys think that this RPM is standing for? Nobody? Nobody want to give it a shot? Okay, I'll give you guys a hint. So remember how in order for the music to play, the record had to be spinning? Okay, so what is another word that for spinning that starts with an R? Jake. So that is a really good guess. Revolving is not the word that we're looking for, but that is such a good guess. Does anybody else want to take a shot? No? Okay. So it's rotations. So we're looking at rotations here because we're going around and around and around. Now, does anybody want to guess what the PM stands for? So we know that R stands for rotations. What about the PM part? Stacy? Yes, per minute. So what does that mean altogether, class? Rotations per minute, exactly. So what does that mean then? It's saying that it's 33 1/3 rotations per minute. But what does that mean on my record? Jack? Yeah, exactly. So did everybody hear Jack? I'll go ahead and repeat him. So Jack said that rotations per minute, it meant that in 1 minute, our record rotates 33 1/3, per minute. So just keep that in mind as we're solving the problem too. So how long, so the overall problem, excuse me, I'm getting ahead of myself. The overall problem is how long is the groove on one side of a phonograph record, okay? So we're trying to figure out how long that groove is, right? So I know probably some of you are thinking, how do you even measure a groove, right? We're talking about a circle. So what we want to remember is that, kind of thinking of it in another way, is if you were to take that needle and have kind of a highlighter on it and observe it as it's spinning around that groove, we're trying to figure out how long maybe that line would be if we're thinking about it linearly. Or if you want to think about it abstractly, you're more than welcome to. So just remember, some key things that we need for this problem, where we know, how many rotations it's doing in 1 minute. And can anybody tell me what that is, what that represents? We talked about, when we think of miles per hour, we think of how fast we're going. And what was another word for that? Speed. Exactly, exactly. So, what do we think that rotations per minute is also representing? Speed, right? So that's how fast our record is spinning, at 33 and 1/3 rotations per minute. Awesome. So, with all that being said, and remember, it's also, playing for 23 minutes. So, using the information that we've gone over, I want you guys to work by yourselves. I'm going to give you about 20 minutes to kind of think about, what we're needing to do to get to that solution and how we're going to go about solving this. And if I see that we're kind of wrapping up, or some of you are stuck, we could always turn to a partner and talk to them as well. But I want mainly for the first 10 minutes to be solely individual work, okay? And before we break off, I want to go over our rules really quickly. We have our 3 rules. So rule 1, what is rule 1? Right. You can never have too many representations. So you're always going to want to try to get as many representations as possible, right? So just because you do it one way doesn't mean that is the only way to do it. Awesome. Okay. Rule 2, what do we do? Right. So for rule 2, it is always, always, always justify your answer. So even if you do find a solution, you need to be able to say why you think it's right or why you think it works for this particular problem, okay? And then finally, rule 3, anybody remember? That's right, respect. We are going to respect our peers' thoughts and thinking processes, and we know that just because we did not come up with that solution, that it might not be wrong, we need to be respectful and listen to our peers' justification. So keep those things in mind. I will be walking around the room, so if you have any questions, just raise your hand or stop me. I will be happy to help in any way that I can. Good luck, guys.